morning, good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Aptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source. Welcome, everyone. Hello, Rose.
Hello, Zane. How's it going, man?
It's going pretty good. If I can get my volume set right. Make sure I can hear you okay. Perfect. There we go.
Yeah. Well, I'm glad I was less and you had to make more. It's really bad when like someone pops in, they're like, ah!
I feel like I do that most of the time. I feel like I never have this thing set quite right, so it's usually just really loud.
Probably coming in strong. Hey, everybody. Thanks for joining us. We are so excited to be here. Today, we're going to talk a little bit about Fuzzball with probably one of my favorite people on the planet. Would you agree?
Absolutely.
Yeah, it's Forrest. Bring him on.
There he is.
There's the man.
The hair, man. It's getting more and more epic every week.
It's almost time for a haircut a little bit. It needs a trim. I just haven't managed to make it to one yet. But
the little bit. I like the little bit part. He's a little bit.
What ends, that type of thing. Good to be on. Good to see you all this morning, actually, for me over here.
What does that mean over here? Where are you?
I'm over here on the Pacific coast, about 5 minutes from the water and 70 miles north of the California border.
Oh, okay. Nice. I'm waving to you. Can you see me?
Almost from here, I think. It's just at some point here, I need to make it over to the our office in Reno and everything. And
Reno, that's right.
Crew over there.
Yeah, that'd be cool. If it ever stops snowing over there, I think it's going to snow the next, just all the way through winter.
It didn't start snowing again, did it? I know it did like week before last. It's not snowing right now, is it?
I don't think right in this minute, but I was shocked to hear that it was, snowing last week. I'm like, is that real? Is that really
like
happening?
104 last week, so snow.
Well, you're like what, in Texas?
Yes, it's very hot.
100.
Very hot.
Yeah, it is. Okay, well, all the niceties and weather aside, which does actually affect our life, so that's why we talk about it, because there it is all around us. We are going to be talking about Fuzzball a little bit today, and I believe, Forrest, that you have a little something to show us. We want to jump right into that part. I like to see it, so I don't know. I'm always like jump right into seeing it, but you want to give us a little update?
Well, yes, absolutely. So today we're here to discuss just a little bit of kind of an update about Fuzzball, kind of, a month or so post-release. As everyone knows, CIQ released both Mountain and Fuzzball, two of our big flagship products last month. Mountain, kind of our big solution around Rocky Linux for bringing patching and, packages, package management, all that type of thing out to that, kind of in an enterprise format. And then Fuzzball, of course, our big flagship platform around high-performance computing that, is kind of our new way of combining the best of enterprise computing with the best of high-performance computing. As I said, it's been about a month since Fuzzball has been out, and we're here today to kind of give a little bit of kind of a review of what's going on with Fuzzball since then, which we'll get to. I don't have anything too specific to show on the GUI or etc. like that today, unfortunately. I was tinkering with something, but I didn't quite get it working in time. So maybe in future release we'll be able to show up, but we'll certainly talk about it a little bit. It's kind of
guessed. Was it AI based?
A little bit, yeah. It's kind of something that we'll go ahead and discuss it a little bit. I guess a capability. This is something that kind of came out of one of our POCs. So part of the reason why I don't specifically have it to show is because it's still a little bit wrapped up in one of those. So it's I would have to kind of take it apart, deconstruct it a little bit to you'd all have to sign an NDA otherwise. But essentially, one big thing that we've kind of been working on lately, kind of in my sphere of things as far as workflows go, is bringing, as said, capabilities around AI to Fuzzball. We've already done quite a bit on this channel with Fuzzball and AI. Last summer, I think about a year ago, we were showing Dolly Mini and that type of thing. Since then, we've run Stable Diffusion. We've done a lot with just in general, kind of the PyTorch, TensorFlow sphere, that type of thing. But one big thing that we've kind of worked on recently is hyperparameter tuning. So in case you don't know, hyperparameters are something that kind of go into AI training. It's different things like, but or could really reasonably explain here. But batch sizes, different aspects of how many result kind of bins basically a model has, different aspects of kind of how it's trained, how data is kind of divided up and delineated out to the different compute hosts that you're using as a part of your AI training. Hyperparameter tuning is commonly done before you're doing like a big run of AI training, so you can know that you're actually doing that training as optimal as possible. It's kind of like a meta-analysis of your training setup before you actually commit tens of thousands of dollars or whatever to go run for a week or 2 weeks or a month on training your AI. So one big platform that a lot of places use for this is called Weights and Biases. Weights and Biases is a big like kind of ML ops platform that allows you to streamline a lot of different operations around AI. As I said, hyperparameter tuning is one of them. So you can create sweeps there where you essentially give it your code, give it the parameters that you want to optimize for, that type of thing. And then given a certain bunch of compute sources, you can actually have it run and test different hyperparameter combinations to determine what's going to work best. As I said, that's kind of something that's a little bit locked in a POC at the moment. But we've been using the Fuzzball architecture to do things like take with just an API key stored in our Fuzzball cluster as a secret. We've discussed previously Fuzzball's ability to, for example, in the cloud, have credentials and other bits of information stored inside of it so that it can be templated out when a workflow reaches it, for example, so users don't have to store their own credentials in it. So they don't have to store their credentials in workflows. They can just store it within the vault on the server, basically. So you can store an API key, and essentially given just your link that you would normally use to run this Weights and Biases agent command, you can go ahead and essentially like a link to your sweep. When you create a sweep on the site, it gives you a link that you can then use and run sweep agents against. And you can the sweep agents scale embarrassingly parallel in an embarrassingly parallel manner. So as you run more and more sweep agents, you essentially can just run more parameter sweeps at once. And so we've been running testing with Fuzzball's task array interface, where we can essentially run one type of task across a whole bunch of different instances at once. Provide kind of embarrassingly parallel it's kind of a generalized HPC architecture where you've got 20,000 input files. You need to do the same little bit of data analysis or data munging or whatever on all those files. So you take your 100 compute nodes and then just run sequentially those 20,000 files through it. So in this case, we use the ability of Fuzzball to have concurrent instances running in a task array to actually run multiple agents at once and be able to control those and be able to see actually out of the Weights and Biases site these instances being run through Fuzzball out on, in the example we're working with, the AWS cloud, actually on the Weights and Biases site as compute instances. This is kind of similar to, we never got to show it much because it got obsoleted, but this is similar to how like crypto mining, for example, worked when we were messing with this on Fuzzball, where a third-party server could delineate work out to a workflow in an embarrassingly parallel manner. In this case, Weights and Biases serves as kind of the third-party server that sends out work to all these embarrassingly parallel instances, and you're able to essentially scale out your hyperparameter sweeps as arbitrarily as you'd like. So that's interesting. Like I said, I tried to get a kind of public version of that together, but I wasn't quite able to. But that's something very interesting that we've worked on lately. I know that's kind of a big capacity that I know a lot of places are doing a lot of hyperparameter sweeps and are expending compute resources on that. So Fuzzball definitely makes that easy to kind of delineate. There was a blog post recently that we put out, or that I put together, that was about how to do these hyperparameter sweeps using Apptainer. And the natural extension of that, once I had a container, was to take it to Fuzzball and see if it would run there. And as I said, with Fuzzball's task array interface, it was really simple to just take the same command I'd been running out on these instances when I was testing it myself, and be able to scale that out through Fuzzball to multiple instances. So that's kind of the biggest, most interesting kind of workflow type update that I have at the moment. And that's kind of some of the capabilities that we've been looking at with Fuzzball. We've got, of course, lots on our roadmap. We're always working and iterating on all of our objectives in light and relative to each other. But Fuzzball remains a topic of great interest at CIQ, and one that me and my colleagues here on the FA team especially are always eager to be exploring new use cases, new workflows, etc. And so so that's kind of one of the most interesting things we've been looking at recently. Like I said, from especially in the AI space, that's kind of a big thing. So that's
Forrest, I know you guys have been working quite a bit on containerizing things, and like you had said, you containerize things and try them out in Fuzzball, see what happens. I hear you guys talking a lot about things like OpenFOAM, ParaView, OpenRadioss. Could you talk a little bit about where those are in terms of containerization, and then kind of what those are used for? Like, what disciplines of science would use those?
Yeah, so we have a number of different applications that we've run on Fuzzball. Informally, we've tested these things. We've kind of seen them run. We're working on, the concepts and more formally, testing those and being able to verify that things work on Fuzzball. But for now, we have quite a few applications that we've tested, built out use cases for, built out workflows around. Like I said, OpenFOAM, OpenRadioss, and what was the other one that you said, Zane?
Oh, it's ParaView. So
ParaView, of course, yeah. So those applications we all have running on Fuzzball. My colleague Brian Fan has done quite a bit of work in the CFD space on OpenFOAM and bringing that to us. So we've got the capability to do batch computing around simulations in that space. We've got our motorbike example, for example, that I'm sure many people in that space have seen running on Fuzzball. And then we can take that and within one workflow or even a single workflow, be able to run the entire the two containers that it takes to do the OpenFOAM simulation, and then a separate ParaView container that generates a visualization off of that. So end to end with OpenFOAM, for example, we can ingest what's necessary. Though I'll admit I'm not 100% sure right off the top of my head if there is data that gets ingested into that right off the start. I think there is. You can ingest whatever data would be necessary for that simulation. It runs the whole OpenFOAM kind of aerodynamics CFD simulation on it. And then, like I said, can take another container and organize ParaView to generate a visualization of that all within one workflow. So yeah, that's really cool. I know that's quite an application of industrial interest in a few different places. I'll admit right off the top of my head, I'm not as familiar perhaps as I should be with how the OpenRadioss workflow goes. But my colleague Yoshi-san and Yoshiaki Senda over in Japan has done quite a lot of work on that. I believe we've got a decent amount of blog posts and stuff like that kind of goes into Rocky Linux and OpenRadioss. I think we just launched out on, I think the Oracle Cloud, or at least one of the clouds out there, an image that you can go spin up right now that's got Rocky Linux and OpenRadioss built into it. So you can start iterating on that immediately.
It is the Oracle Cloud. You are
very
correct.
Cool. Yeah, so that's out there. You can go, like I said, work with OpenRadioss on a Rocky Linux base today by just spinning that up there. But on Fuzzball, like I said, I'm perhaps not as terribly familiar with exactly how that workflow goes as I should be. But as far as I've seen, that runs on Fuzzball. We're able to take the similar types of examples that we've run, kind of, I believe, in his blog posts and things like that. And I've put them into YAMLs, run those, tested them around. As I said, that's another application of large industrial interest. And so with that kind of entering the open source sphere after Altair released that, as we've seen, being able to run that on Fuzzball and do all those same types of things that you've seen him do in his blog posts, etc., is very significant within the Fuzzball ecosystem. So,
and I believe that David Godlove took Yoshi's work and actually did it on a webinar. So we actually got to see a car crash, if I'm not mistaken, that we can actually link to.
I think we can. Yeah, I believe we did that. I think I remember that not too long ago. Wait, we've done so many of these by now that sometimes
No,
I think I was
Sam put so much
other
work
day.
into it and got it working, and then Dave Godlett was able to recreate it. So we can put that link in there, and you can go watch that if you're interested in seeing it in action. Again, thank you, Yoshi and Dave, for doing that.
Yeah. So yeah, we've, like I said, between Brian, Yoshi, we've got quite a lot in CF, where we've covered some interesting applications in CFD and kind of the finite element analysis sphere there. So yeah, like I said, those are two big industrial applications that are used in a lot of different places. They're of a lot of interest to people. So.
That's cool.
Good. Sorry, Rose.
Yeah, no, I just feel like I got to pop in and say sorry, Forrest, for putting you on the spot for a demo. I thought it was gonna.
No worries at all.
Live surprise demos, those are the best. Come on.
A surprise one. Like, can't you just do it live? Just like make it happen. No,
live.
That's awesome.
Yes, I wish I had my magic hat to pull something out of, but like I said, I did try to get that one privatized, but ultimately the underlying code base is difficult to not reveal, and I haven't had a chance to kind of get together a little bit of hyperparameter tuning code of my own. But at some point, we will we'll definitely show that off. There are people in the private sphere that were very interested to see that come out and be in action. So.
Yeah,
I feel like we should really make this interesting and give him a deadline.
Ooh,
just go add it to his Jira board, like force the issue.
Do we have access to that? Could we go in there?
Yeah, last year nightmare.
Not.
That would be awesome.
Jonathan would love that.
Perfect.
Oh man,
yeah,
that's awesome.
Yeah. Well, we've got not only that, we've as we kind of touched on a little bit, there's quite a lot that we've done with AI on Fuzzball as well. Just to kind of maybe go into a little bit of a review of the applications and type of things that we've done on Fuzzball so far. As I said, AI has been something that we've been working on quite a bit, kind of in general, not only within Fuzzball, but in the Rocky Linux sphere. In the past year or so, we've been working really hard to kind of create a basis of practice around AI on Rocky Linux by bringing big frameworks and stuff like that to it. As I've noted at a number of different times, we've run models like Stable Diffusion and things like that on Rocky Linux, and then taken those directly to Fuzzball and been able to run those there. At this point, Stable Diffusion is like one of my standard demos that I use at quite a few different things because it, being just a PyTorch, being ultimately just a PyTorch-based AI model, PyTorch runs great on Rocky Linux. It installs just fine, and so there's not really any issue getting that up and running on GPUs, up and running on that type of architecture, and then especially translating that to Fuzzball. So as far as PyTorch goes, we've done quite a bit of sophistication on Fuzzball, just by virtue of the fact that a lot of the major kind of interesting, fun to demo use cases are built on that. I arrived at SC and I saw a couple other folks also running Stable Diffusion on their architectures. So that's been interesting.
There were a few.
TensorFlow, we've also run on Fuzzball. We've got the classic MNIST example, that type of thing. We haven't dove too deep into running some of the massively TensorFlow-based models out there, just because we haven't run into those use cases yet. But yeah, we've run TensorFlow, we've run examples like that. As said, we've kind of in the sphere of more of Rocky Linux. We're working at the moment on supporting the Rocky Linux special interest group around AI. And so just here in the last couple of months or so, that was founded, and myself and a couple of others are kind of interested in seeing where that goes, kind of helping to support, as I said, kind of bringing some of the practice of AI into Rocky Linux and giving people that, here's the actual guide that shows there are people that are, working on this out there. So TensorFlow and that type of thing, we've tinkered around with. And as I said, we've got definitely an example there that we've worked on with Fuzzball. Other things in AI, as I noted, let's see here.
I got a question for you while you're looking for us.
What's up?
That special interest group, that SIG, is that something we should post a link for? So
yeah, absolutely.
Find it very quickly if we don't mind doing that.
Yeah, we'd love to have more people
awesome.
coming on in there and contributing to, as I said, helping to make Rocky Linux the best environment for AI that it can be.
I think that could be a really cool place to spend some time.
We have meetings every Thursday. I think our next one is next week. Yes. Our next one is next week at 9:30 Pacific AM. So yeah, feel free to come and join us. They've been a little quiet for a second. So yeah, we'd love to get more people on and have more people involved there.
Excellent.
But yeah, so TensorFlow we've tinkered with. We've got things like GPT that we've worked on a little bit. As far as JAX, things like that, I couldn't point to a complete workflow, but mostly because a lot of my tinkering has been kind of just working with GPT in general on Rocky Linux, and just kind of, as I said, the JAX framework that underlies some of that. Kind of in the context of TPUs, that type of thing. But we're working on kind of figuring out what's sticking around in kind of the open source generative AI space. Of course, we're real big on open source AI with Fuzzball. That is kind of a very fast moving space, especially around large language models at the moment. So we're kind of seeing what sticks around, seeing what ends up being kind of the major use cases there. But as said, we've already built out large scale models with PyTorch and that type of thing. So as far as GPT inference, all that's what we're heading for. So yeah, AI is proven in a lot of different ways out on Fuzzball, and just kind of in general on Rocky Linux at this point. So yeah, AI frameworks, models, those are always fun. We have other applications that we run on Fuzzball. I think that we've tinkered with quite a bit on this webinar. For example, in bioscience, we have quite a few different experts at CIQ kind of in that sphere, as HPC and bioscience tend to go hand in hand in many cases. So for example, we've worked on GROMACS, which is the big molecular science or molecular dynamics application that a lot of places have, or a lot of places are probably familiar with. That gets used in pharmacology, that gets used in private academic research, that gets used in biological research of all different types. There's an interesting publication out there from AWS that kind of goes over price performance ratio with GROMACS on AWS when you use their Elastic Fabric adapter. And so something interesting that I was working on kind of earlier in this year, my colleagues and I, proving out, and gradually we've been working on this for quite some time, but just always, benchmarking and things like that. Earlier this year, I was doing some benchmarking with the Elastic Fabric adapter support that Fuzzball has. When you're running an MPI on Fuzzball with the AWS provider that we have at the moment, you're able to use EFA placement groups to make sure that all of your instances are getting placed in like cluster placement groups, that type of thing, so that they can communicate most effectively. And looking at, for example, numbers that AWS has published for their performance that they're getting on instances, it's nearly identical to what we get at a Fuzzball when we run basically that same test informally. But we're essentially, we're getting very, very close to the same nanoseconds per day performance that AWS gets out of that, to the point where with a little bit more tuning on the GROMACS side of things to kind of optimize how that's compiled on a container level, it would be, it's already very nearly identical. So there's not, like I said, most of the distance is just, in kind of taking the time to compile things versus that specific architecture. But when we run this, like I said, versus AWS's numbers, we get almost exactly the same performance that they report. And so Fuzzball, as far as being able to replicate that type of thing and the performance that people are used to with the EFA and stuff like that, for these large scale cloud batch computing jobs, there's always testing to come, but from what I've seen at the moment, just to give GROMACS as an example of an EFA enabled application that we've spent some time, compiling with all that support, and that we'd like to potentially be able to make available to people eventually. the performance that we've seen is almost exactly what we expect based on those type of publications that are out there. Further in bioscience.
I was going to ask, what about STAR?
Yeah, that's what I was
headed next. All right, perfect.
Exactly. Yeah, there's there's a whole host outside of GROMACS of other things that we do in bioscience, like genetic sequencing, that type of stuff. So being able to take, the genes that are present in a sample, match them versus a genome, and figure out what those genes are. This is an incredibly common task in any, genomics lab anywhere in the world, and is mostly a high performance computing powered task. And so, we've built out workflows around really common bio apps like SAMtools, HTSeq, STAR, those type of platforms that I'm sure many folks will be familiar with. I can't, as with many things in HPC, I casually know of these things, but can't count myself as, one of the very valued domain science experts that we have in them. But I know that there's a lot of use around STAR and those type of things out there. And those were some of the first. Actually, I think the STAR workflow, come to think of it, the SAMtools HTSeq STAR workflow was the first workflow I built at CIQ that we converted from a GitHub repo that had a lot of Python code and things like that did like S3 transfers and data movements and a lot of things that I was able to strip out and just kind of leave to Fuzzball in the end.
And it seems like yesterday, and it was almost 2 years ago.
Yeah, I know, right? Gosh,
Crazy.
Absolutely crazy.
Wow, Forrest. Oh, you're still going. I was gonna jump in here.
What's up, Rose?
Well, so I get a lot of calls and emails and requests from universities, and there's several universities that we're working with now, and lots of them that have been like coming in and asking questions. I literally got one this morning from a university, and they said, "Fuzzball looks cool." I want it. I'm like, cool. Yeah, absolutely. Let's talk about it. Let's, set up a meeting. We'll do an actual demo. We'll figure out what it is that you need. So talk to me about the academic world and where Fuzzball kind of fits in there, what we've been doing with these universities.
Yeah, so the academic world is very near and dear to my heart because that's how I got into HPC. And that's kind of how I got specifically into kind of the concepts that we have around Fuzzball and HPC. As we kind of noted, I think on one of our past webinars, I came from the academic HPC environment, was there for about 2 years or 2.5 years or so. And while I was there, heard quite a bit from researchers that they wanted solutions around automation like Fuzzball. They were exploring, other workflow engines, they were exploring other platforms. But being, kind of one of the overworked and overtaxed admins on this cluster already, those solutions take a lot of time to put together. Those solutions take a lot of time to investigate. That was, kind of a whole different sphere of things that we were able to dip into a little bit, but we were never able to get to kind of the level of complete automation that we wanted to reach for our researchers. So I was always looking for a better solution. When I saw Fuzzball, I was like, oh, great. This is very similar to what I, had been thinking would be, kind of the next phase here. I think Rose, we alluded at a past webinar to my, diagrammed out, kind of simplistic concept of having, all your containers on this side, def files over here, and kind of this SSH based login thing that would like drop a user into a container that they then couldn't like knock out the rest of the system from, with like running on head nodes, that type of thing, because we didn't have a login node at that point. So, anyway. Yeah, so there was a lot of, kind of interest and excitement that me and my colleagues in high performance computing, around me had for kind of that whole sphere of automation. And so I think Fuzzball, a lot of folks in academia will be very excited for that type of thing. Just in general, the solutions and just the simplicity that you can reach with just the underlying technology of Fuzzball, like for example, containers. When I was working with containers in academic HPC, instead of having to go set up a whole build environment, in the clusters area, own the whole file system to the new files to myself, so I didn't, accidentally knock out the rest of the applications folder, build things, scrub the area or, scrub the file system there if a build failed. Being able to, take just a delineated instruction set of how to build an application in a container, build that, make it available in a shared space on the cluster for users to be able to access was such a game changer for kind of how, as an admin, I could do my work, that I almost never wanted to go back to just like building applications manually. I'm like, oh my gosh, I can use my workstation or wherever, a spare compute node or whatever. Or sometimes that was a little bit difficult because of how those were set up. But yeah, I could use my workstation or whatever to go build one of these containers, upload it. I can build it exactly like how I want. I have my whole, build script basically right there that will take, this container from nothing to my application, essentially automatically, as long as I keep it updated. And once I have it, like I said, I was using Singularity, which became Apptainer. So it's a single flat file on the system that, I can just make available in a scratch space or something like that. Yeah, the technology that underlies it is fantastic. And I think when you combine that with the ability to do away with some of the practices that really hold academic HPC back as far as management goes of clusters, and kind of some of these technologies that were not built with some of the technologies that we want to integrate in mind from the start. If you can, ultimately with our vision for Fuzzball, if you can take that and replace that whole architecture with something that's much easier to manage, it's like, as I said, it's a complete game changer for academic HPC and kind of how that whole sphere of things works. So yeah, very exciting. Yeah, it's very exciting. The implications, as I said, for Fuzzball for academic HPC. We've built out a number of applications kind of in that space. Some of the first open source applications that I started looking at on Fuzzball were things that I was familiar with from academics. So like, for example, Gromax was one that I started into. Lamps I knew was a big use case. Quantum Espresso, QMC Pack. I don't think those have seen the light of day on the webinar for some time, but I believe at one point in the past we did show them off. At the very least, those are things we've tinkered with. Some of these applications are things, like I said, we're working in certain ways to, bring to our customers and things like that. But yeah, academic research, we also, while it doesn't generally get used out in industry, some people are interested in kind of working with what are called PGAS networks, which are kind of a different way of doing multi-node parallelism that's separate from MPI, where instead of having cores passing information over a network between each other, you have one basically big global shared memory space that everything puts memory in and out of. And it kind of, is more like the shared memory model of, kind of communication than a network-based one. And so if you're working with the Chapel language, we have specifically a multi-node runner that can take Chapel and GasNet and wire that up so that you can run that on your system. So that's very cool.
So cool. Forrest, honestly, you guys can see why he's one of my favorite people. Just like, it's like, oh, I'm not an expert on that, but let me just, bust out my encyclopedia of knowledge about this question that you asked for. So the best ever. We could probably talk for the next 3 hours just about what's going on and where things have been and where they are right now. Do you want to maybe just as we're wrapping up here, and then we're going to take some questions, guys. So if you have questions, please pop them into wherever you're at. We've got people out there looking, and they'll pop them in here, and we will answer all of your questions because we are live and we love to do this live. So wrapping up here, are you at liberty to tell us anything of what we can expect?
He's still there. Don't worry.
Okay, cool. What's in the future for Fuzzball? Because it's not a complete product. I imagine that it will never be complete because we're always iterating on what our customers are asking for, what the community is asking for, and we're constantly evolving. But can you hint at a couple things that are coming?
I believe I can a little bit within reason. Really quickly, just really quickly. One other interesting thing we've been working on recently are benchmarking suites within Fuzzball. HPL, Phoronix test suite, maybe not Phoronix test, but Phoronix benchmarking suite, sorry. And then in the far past, we did HPL AI, and we're able to get, once again, matching performance numbers based on that benchmark on some systems that some large scale GPU and AI systems we were doing those on. So while those aren't immediately useful for people, I'm sure everyone interested in still running that standard HPL LinPack burn-in, you can still do that same thing with Fuzzball and get those flops numbers out of it. So what's coming up next? Two big things kind of in my space of things that I know we are kind of working on in the workflow sphere of things. We'd like to be able to bring some popular IDEs to Fuzzball. So we're kind of working a little bit on tinkering around with bringing things like VS Code, Insight systems, some workflows like that into something that Fuzzball can do. We'd like to be able to, perhaps should we remote develop, remote GPU profile, etc., those type of things. It would be very useful if somebody could take their AI code, run a simple profiling workflow against it, and then be able to get the profiling reports and everything like that uploaded out to S3 automatically once that's done. And so we're working, especially kind of on my team, the SA side of things, around stuff like that. I know we've looked at, for example, VNCs, and I don't quite remember where our exact where we've left that off at. We're looking at bringing capabilities around R into Fuzzball. We'd like to, once again, another thing that I don't quite remember the capabilities right off the top of my head of, but that we've worked on with our Studio Server and things like that. Being able to, run like R development and things like that remotely from Fuzzball workflow. These all kind of in the same vein generally as our Jupyter Notebook workflow that we've seen on this, which I should note also works on Fuzzball in the interactive sphere. Much of what I've discussed today has been batch computing based workflows, but we also have interactive capabilities in Fuzzball around port forwarding. And so a lot of kind of the interest that we have in workflows at the moment is around seeing how those capabilities can build out. And like I said, bringing more kind of benchmarking capabilities to Fuzzball around especially AI and kind of being able to burn in those systems and that type of thing.
Excellent. I think we do have one question.
Oh, wait. Question time. Oh, wait. There we go. Questions. Oh, is this backwards? Oh,
backwards?
Man. All right. Well,
No,
I thought it was
good.
fun.
It was good. So hyperparameter space exploration can get expensive in time and resources, Forrest. How do you forecast and condition it so that you get a good balance of enough versus not enough?
Well, I think that comes down to knowing, especially like, for example, from the Fuzzball perspective, what compute resources and that type of thing you're running on, and ultimately the underlying cost of use for those. Is this something where you can run these on-prem architecture, or you can run your on-prem infrastructure, and it's not going to, amass cloud costs maybe as fast as using cloud GPUs are. In general, being able to, tunably scale kind of with how Fuzzball makes that possible, how many resources you're dedicating to it, being able to keep track of how long a workflow is run for, that type of thing, is very useful. While it's, kind of more so on our Fuzzball roadmap, metrics and tracking around that type of thing is something that we're working on, kind of putting together planning and code bases and stuff like that around, so that you can have visibility into costing and things like that easier wired into that. So while I, once again, I am only an amateur AI research scientist, so I would have to say that I couldn't specifically say how you would forecast and condition it, on a technical level. But like I said, with regards to kind of how Fuzzball and what we're building out with containers and that type of thing, it definitely gives you the ability to easily scale up, scale down, and kind of tune relative to what capabilities you want your users to have, how quickly and how much that is going to end up costing you in the end.
Amazing. Forrest, thank you so much. I don't think that we have any more questions, particularly for today for Forrest about Fuzzball. But if you guys have anything you're watching later and you want to know something, just go to our website submit a little form. You can type it in here in the comments below. There's a million different ways to get a hold of us. We want to talk to you. We want to meet with you. We want to chat with you about what's going on in your environment and how we can help, and dive into details about how this particular product called Fuzzball can help and support the amazing work that you're doing wherever you are. So make sure that you give a like, you give a subscribe. We'll be back here, same time, same place next week. We love you very much. Have a great day.
Thank you, everyone.
Thank you all. Goodbye.